Alright, so welcome back. This video you are going to learn how to write names and formulas using polyatomic ions. So this is really no different than what you've been doing previously with normal metals and transition metals, but instead of just using a normal element for your anion, the ending, you're going to use a polyatomic ion instead. So it's still an ionic compound, so you're still going to make sure that your charges cancel out and equal 0. But whenever you're writing the formula, the big thing is that instead of just writing however many you need right after it, you're going to have to put your polyatomic ion in parentheses, because otherwise, here, this is saying that we need 1 aluminum and then 3 NO3s, okay? If we did not have the parentheses, you would be telling me NO33, 1 N and 33 O's. That is not the same as 3 NO3s. So those parentheses are super important. So you would make the charge cancel just like how you always have, either using that crisscross method, right, where you take the charge of one and bring it down and make it the subscript of the other. Or you can add up your charges and make sure that they cancel. Okay, but remember, if you're using this crisscross method, then you have to ask yourself at the end, can it be simplified? So here, we have a 1 and a 3, so you can't simplify that further. You can't divide it and make it smaller and keep it as whole numbers. So we're done. Okay, now, you might be wondering, what the heck are these polyions? Well, if you look at your formula chart, and let me get y'all's out, on the very back, you have a list. These are polyatomic ions. So polyatomic ions it's a compound made up of nonmetals. So instead of just having a single nonmetal, you have a couple of them, and they all have a charge. And you're going to use that charge to cancel it out just like you would any normal nonmetal. Okay, so whenever you end up with a compound that has more than just 2 elements, that means that you're going to have a polyatomic ion, so you want to get your periodic table, look at the back, and find the list to figure out what you've got. Okay, so looking here, this iron 3 sulfate. Well, we know what iron is. Iron, according to our periodic table, is Fe. And remember the Roman numerals here, that's Roman numeral 3. That's not telling me that I use 3 irons. That's telling me that the charge of my iron is +3. Okay? And now it says sulfate, and that's how I know I've got a polyion whenever I'm looking at the name. The name ends in ate, A-T-E. That's telling me that it is a polyatomic ion. If it ended in I-D-E, then it would be an element. But because it ends in A-T-E, or it could end in I-T-E, that means it's going to be a polyatomic ion. So I'm going to look at my polyion list and try and find sulfate. And when I do that, find it down here at the bottom. So sulfate is SO4 with the charge of -2. So I would have SO4, -2. And you can choose to cancel them out either by adding them up to equal 0 or doing that crisscross method, whichever you prefer. But you'll figure out that you need 2 irons, my bad, 2 irons and 3 sulfates. So whenever you write it, iron is what's listed first in the name, so iron is what we write first in the compound, and I need 2 of them. And then I've got sulfate. I need more than 1 sulfate, so I have to put that SO4 in parentheses. And then I'll put however many I need, which is 3, outside. Okay, so I want you to try, so pause the video and I want you to try with zinc chlorate and then come back and we'll walk through it. Alright, so zinc chlorate, so the element for zinc, the symbol for that is Zn, and if you remember from day 1, zinc has a charge always of +2. Now, chlorate, ending in 8 tells me it's a polyion, so I'm going to go and look at my list. And then here's chlorate. It's telling me it's ClO3 with a charge of -1. So now I've got my charges. I need to make sure that they cancel out and equal 0. So if I wanted to do the math, I could do plus 2 minus 1. But that doesn't equal 0. If I add another minus 1, now it does. So I used plus 2 once, so 1 zinc. And then minus 1 twice, so 2 chlorides. So I'll start with Zn. I used it once. We never write ones. It's redundant. We don't want to, just by writing it, we're saying that we've got 1. And if we've got more than 1, then we would write how many. So we just write Zn. And then we followed up with ClO3. But I need more than 1 ClO3, so I have to put it in parentheses. I used 2 of them, so I put a 2 outside. Now, whenever you are looking at the name or writing the name, spelling is super, super important because that ending is going to tell you whether or not you're dealing with a polyatomic ion or you're dealing with just a regular nonmetal. And even specifically what polyion it is. So here, we're dealing with ammonium chloride. That's NH4Cl. Ammonium chlorate is NH4ClO3. Whereas ammonium chlorite is NH4ClO2. So the ending is super, super important. For polyatomic ions, we do not change the ending. We keep it as it is. We only change the ending whenever we have a single nonmetal at the end. Okay, so let's look at these and name them. So Na2SO3, so Na, that is sodium. Then SO3. So I have more than 2 elements here, so that tells me I'm going to have a polyion. So I'm going to go and look at my list for SO3. And whenever I do that, I'll find it down here. That's SO3. And its name is sulfite. So all I'm going to do is write sodium sulfite. I do not need any Roman numerals because sodium always has a charge of +1. So since the charge is always +1, I don't need to write that with Roman numerals. Okay, I'm going to do the same thing here. So Ca, that's calcium. Then I see that it's ClO4. So ClO4, well, that's right here, and that's called perchlorate. So all this is going to be is calcium perchlorate. Okay, pause the video. I want you to try this next one on your own and come back and check your answer. Alright, so this one was NH4,3. So because there's parentheses, that automatically tells me that I'm dealing with a polyion. So I'm going to look for whatever's in the parentheses. That's NH4. Well, that's this top one right here. That's ammonium. So I'm going to write ammonium. And then PO4. That's another polyion because it's more than one just single element. So I'm going to look. And then PO4 is down here at the bottom. PO4 is phosphate. So it's going to be ammonium phosphate. Now you may have noticed that this list contains the charges, but in your compound it doesn't. And the whole point of that is that we are figuring out how many we need of each one to cancel out that charge. So in your formula, you never write the charges. So just because this isn't PO4 -3 here, doesn't mean it's not phosphate. It just means that the -3 from the phosphate was canceled out by the 3 ammoniums. Alright, so if you have any questions, please come see any of us. We are happy to answer those for you. Have a great rest of your day.